APIs, the invisible connections between applications. Applications can be very complex. When you open Spotify and press play, it looks simple, but that button triggers a whole factory of tasks inside the application. Songs are fetched, decoded, tracked, and logged. All this in the background. But the play button didn't do all that work itself. It sent a request. The application received that request and did all the work behind the scenes to deliver the result. That's what we call an API. A simple request on the outside, triggering complex work on the inside, and returning one single clear response. My name is Diego, I'm a network and systems engineer based in Paris, and I like breaking down tech concepts into simple and visual explanations. If you want to see more videos like this one, feel free to subscribe. And that's all. Back to the video. Imagine a very small application, a music app that only plays sound. It doesn't care about buttons, screens, playlists, or recommendations. It only knows how to play, pause, and move between songs. Inside, even if it is a simple app, there is a lot of stuff happening. But none of this is visible from the outside. The only thing that is visible is a small menu of actions. This is the only way to interact with the application. You cannot reach inside. You can only ask it to perform these actions. This menu of actions is called an API. An API, or Application Programming Interface, is a defined list of actions that an application exposes to the outside world. Each action is usually written like this. These actions are often called functions. The parentheses show if the function needs extra information to do its job. For example, the function pause doesn't need anything. That's why the parentheses are empty. When you call that function, our music app will simply pause the current song, no matter what song it is. However, this other function needs more context. The music app needs to know which song to play. So when you make a request to that function, you must specify the name of the song. These values that you send inside the parentheses are called arguments. So the next question is, how do we interact with the app? How do we trigger these actions? For that, we can add a user interface. The interface will show familiar buttons to the users, and each button will trigger a request to our API functions. When you tap play, we call this function. When you tap pause, we call this one. And when you tap next, we call this other one. The interface doesn't know anything about buffers or codecs. It never reaches the inside. When you tap a button, the interface is simply sending a request. Please run this action. The music app receives the request and takes care of all the work internally. Then it replies with the result. And just like that, your song starts playing. At this point, we already have a working application, a music engine, an API, and an interface. Let's say now we want to add a new feature, playlists. Instead of recoding and putting everything into the music app, we can simply add a second component, a playlist component. Its only job will be to manage playlists. It will have its own API or menu of actions. For example, create playlist, add to playlist, and play playlist. Now we simply need to add more buttons to our interface to call those actions. And you're about to discover one of the coolest parts of APIs. A component can have its own API and at the same time use the API of another component. A good example for this is that the playlist component doesn't know how to play audio. It doesn't have all these decoding machines inside. So for example, when we call the function play playlist, it doesn't play the music itself. Instead, it looks at the playlist, chooses a song, and sends a request to our first component, asking it to play song. So now we have a chain of APIs. The UI calls the playlist API, and the playlist calls the music API. This is how real applications are built. Each component focuses on one responsibility. Each of them exposes a small API, and they can use other components by calling their APIs. This is why APIs are so important. They let applications grow by adding new components, instead of rebuilding everything each time. The next one can be a recommendations component. And when you put all these components together, you get something familiar. Music, playlist, recommendations, and a user interface connecting everything. We have basically built something like Spotify. Big applications like Spotify are not one big block of logic. They are collections of small components, each with a clear responsibility, and all of them talking to each other through APIs. So far, every component that we have mentioned is part of Spotify. But what if another company wants to interact with Spotify? What if Amazon wants to play music on one of their devices? Alexa is a complete separate application built by Amazon. It doesn't know how Spotify works internally. Instead, it interacts with Spotify using its API. So when you say, Alexa, play Spotify, Alexa triggers an API call to this Spotify function. Alexa, pause becomes this one, and Alexa, next becomes this other one. From Spotify's point of view, nothing is different. A request comes in, and it runs the action. And this idea is not something specific to Spotify. When you order food online, the app makes an API request to send your order. When you request a ride, the app makes an API request to find the closest driver. If you think about it, most of what happens on the internet is possible thanks to millions of APIs talking to each other. If this video helped you to understand APIs better, give me some feedback in the comments. I will appreciate it. Thanks for watching and see you in the next one.